That's the Perseverance rover. It's a Perseverance rover on Mars.
Oh my gosh, that's awesome.
Yeah.
Well, first off, Elon, thanks for coming to the X Takeover, formerly Tesla Takeover, for the second year in a row.
You're welcome.
Well, let's kick things off. Let's start off with really your baby, the Starship. Starship is the most ambitious rocket ever built. What's been harder than expected, and what's the next milestone we should watch for?
Well, I thought everything would be hard, so it's not like I was like,
It would be easy.
yeah. It's just, Starship is a crazy program on so many levels because you've got something with 2.5. And future versions will be 3 times the thrust of the Saturn V moon rocket, which was previously the largest rocket and largest flying object ever made. So Starship is 3 times the thrust, roughly twice the weight of the next largest flying object ever made, and has the goal of being fully and rapidly reusable. So this is a really crazy thing. I think it's really one of the hardest engineering challenges that exists. When we first started talking about Starship, people thought this was impossible. In fact, even within the company, we sort of thought it was impossible, and it had a very high sort of what I call giggle factor. You mention the thing, and people immediately start giggling like at the absurdity of it all. But now it's gone from, I guess I specialize in going from the impossible to the merely late. So that's my skill. It wasn't possible, now it's just late. And I encourage anyone who's interested to go and visit Starbase in South Texas. It's like a magical land with gigantic rockets. I think some of you have
it's insane.
It's very inspiring. It's like a take friends and family. It's on a major highway, so you can see things quite close up, and really get a sense for the scale of the rocket and the factory and everything. So it's very cool. I guess the thing that I thought would be hardest currently is the hardest, which is the creating a fully reusable orbital heat shield, which has never been done before. So normally the heat shields are they're expendable, and even say for the shuttle heat shield, they would lose many of the tiles on every flight, and they'd have to refurbish the heat shield between each flight. So it's never, no one has ever created a fully reusable orbital heat shield before, and no one, in fact, no one has created a fully reusable orbital rocket before. And Falcon 9 is the first rocket where there's at least the boost stage is reusable on a regular basis, and where it actually makes economic sense. So solving the heat shield problem is, I think, probably the single biggest remaining challenge for Starship. And of course, getting the upper stage or the ship to land and also get caught by the giant metal chopsticks, which looks like a sci-fi movie. It looks like an improbable sci-fi movie. The whole thing.
Chopsticks, literally catching it.
Yeah, giant metal chopsticks. That's it's pretty wild to be catching the largest flying object ever made with metal chopsticks out of the air. But I'm hopeful that the ship will be recovered maybe this year, but certainly I'd say in the first half of next year. And then there'll be further improvements to make the ship and the booster not just reusable, but fully and rapidly reusable, which will actually drop the cost per flight, cost per ton of payload of Starship below that of a Falcon 1 rocket, of an expendable Falcon 1. So that getting 100 tons or more to orbit of useful payload will cost less than a rocket that would ordinarily deliver half a ton. That was Falcon 1. And it's because all you're doing is replacing the the fuel and oxygen in the rocket as opposed to building a new rocket. And most of the propellant is actually oxygen, not fuel. It's almost 80% oxygen, 20% fuel. Then the next big technology challenge after being able to achieve full reuse of the ship is orbital refilling, where we actually refill propellant from orbit, like aerial refueling. In this case, it's orbital refilling. I say refilling, not refueling, because most of what's transferred is actually liquid oxygen as opposed to fuel. So for orbital refilling, you need to have two starships come together and dock and transfer propellant from one starship to another, and then in the future to an orbital propellant depot. Yeah, so that's the situation.
Doesn't sound hard. Just
I mean, it is very achievable. There's nothing impossible is being talked about here, but it is very tricky to do, and no other organization is even trying to do this. It's not like well, who else is trying to do this? Well, nobody actually. So, in fact, even after all these years, there's still no company that's reusing a booster. So no one's even tried to develop a 9-level reusability. Even though we've shown that it clearly makes a ton of sense, because compare the cost of any form of transport, where if you have to throw away the item afterwards, like if every time you drove somewhere you had to throw away the car, you'd be, wow, that's a crazy car where you have to throw away after every time you drive it. But that's how it works for rockets. So that is really, I don't think anyone would be driving a car if you have to buy a new car every time you drove somewhere, and then you have to tow another car behind you for the return journey.
Elon, what does a
So yeah.
yeah.